Okay, so how about for example 11? We are given a hoist motor supplied by 220 volts. So 220 volts, that's our voltage. We have also 12 amperes. Okay, that's our current, of course. And it is to lift a mass. Take note, class, mass is 1 ton at the rate of 8 meter per minute. Okay, 8 meters per minute. Okay, determine the efficiency of the system. Take note, determine the efficiency of the system. So we are required to solve for the efficiency. By the way, this is the symbol for efficiency, class. Epsilon, Greek letter epsilon. Okay, so what will be the formula for this? Okay, so recall, class, that efficiency is power output over power input times 100%. Of course, you have to express it in percent form, the efficiency. So in our given, if you can observe, we have voltage and current. According to the problem, this is the supplied voltage. So when we say supplied, okay, is it input or output? So when we say supply, this refers to our input. Okay, so to solve for the power input, okay, so we simply multiply voltage times the current, which is this voltage should be the voltage supply. Okay, so multiplying, we have 220 volts times the current, which is 12 amperes. That is, using your calculator, 220 times 12, there we have 2640. So 2640, and the unit is in watts. Okay, that is your input. Now how about for our output, class? How about for our output? Where can we get our output? Take note that we are given here mass and rate. Now if you could recall, class, power can be solved by voltage times current or resistance or voltage whatsoever. But aside from that, we can also solve power by using work, right? If you could recall, work is power times time. So from here, we'll be able to solve for power by dividing work times time. Okay? Now recall that work is force times distance, right? So force times distance, which if you notice, okay, this force is taken, which is equal to the weight. It could be this force is the weight of a person. So since our given here, since this problem refers to the hoist, which refers to the somewhat elevator, and it carries the mass of maybe a person or maybe the hoist itself. Okay, so it could refer to the weight. Our force refers to the downward force, which if we compute, weight is mass times the acceleration due to gravity. Because if you notice, class, the direction of the hoist is going up. So if it is going up, so it will lift the weight of the hoist itself, and it will be computed. Take note, mass times gravity. Okay, so in our given, we are given here mass, which is 1 ton. 1 ton, class, is equivalent to we have here 1 ton is equivalent to 907.185 kilograms. Okay, we have to convert the unit into the standard units. Okay, so this is equivalent to 907.185 kilograms. Now that we have the mass, so we may be able to solve for the weight, which is 907.185 kilograms times our acceleration due to gravity, which is 9.81 meters per square second. Okay, so take note, your unit here will become Newton. So 9.81 times 907.185 there. So you'll have 8899.485. Take note, kilogram times meter per square second is Newton. Okay? But this is not our unknown. Okay? Our unknown is this output. So going back here, okay, we will substitute. This will be our not the this is work. This is not weight. This is our weight. Okay? So we will substitute it here as our force. Okay? Now take note, class, where will we get this distance over time? So if you can see here, we have distance over time, right? Meter is a unit of distance, while minute is also a unit of time. So this means that this quantity here is, you say rate, is how fast your hoist motor is moving. So this refers to velocity. If you could recall, velocity is, or speed is, distance over time. Okay, so from here, class, from here we have to convert first this minute into second. Okay, so converting distance over time, so this is 8 meters per minute. So we have to convert 1 minute is, there are 60 seconds. So in order to cancel this out, so 8 over 60, that is 2 over 15. So we have 2 over 15 meters per second. That is your rate. Okay, now going back here, we will substitute our force, which is equivalent to 8899.485. Take note, the unit is Newton. Okay, Newton times this quantity d over t. This is here. We have 2 over 15 meters per second. Okay, now how much is that? 8899.485 times 2 over 15. There. There, can you see it? There. So we have 1186.598. Now, what will be the unit, class? Take note that this unit here, Newton meter, is equivalent to force times distance is work, right? And this time unit there, so that is equivalent to what? It will be your joule, or watts also, I'm sorry, that will be watts. Okay, so again, this is this Newton meter per second is equivalent to watts. Okay, so this will be our power output, class, power output. Okay, so going back, again, this is in watts. This is our power output. This is our power input. So going back here in our formula of efficiency, here, so substituting, power input is 1186, this one, 0.598 watts, all over your input, which is 2640 watts. So times 100%. So from there, your efficiency will be, so we have 1186.598 over 2640. And then multiply by 100%. So we have 44.947. This is in percent already. So class, this is the answer for example number 11.